Okay, so again we've got tangents. Now when we've got tangents, we know when we go to the origin that that's a right angle, right angle, right angle, right angle. Okay, and because we know these two are right angles, we know that these two are the rest of the four-sided shape. So we've got 360, take 90, take 90. That's 4 lots of x, that's x. This is 5 lots of x. And because these two, well, these make 180, these make 180. So 5x equals 180, and you can solve it. Okay, next one. Hopefully this will give you some ideas. This is one of the rules that's a bit of a anomaly. So we've got a tangent here, okay, which means to the origin, that's going to give us a 90 degrees. Now, it's a very, very simple idea. What happens here is this angle, because these three angles will be these three angles, this angle here is diagonally opposite, and this angle here is diagonally opposite. So you've already got 55 and 42, so work out this angle, and it's x. Okay, so on this question, question 13, we're asked to work out CAD, so we want to work out from CAD, so CAD, so this is the angle here we want to work out. Now, at the very beginning of this we said make sure you're getting your head around isosceles triangles. So from the origin to the outside is a radius, from the origin to the outside to the circumference is a radius, so those are the same. So this is an isosceles triangle, so that's 42, that's 42. Okay, right, next one, we've got ACB, so we've got ACB. Now on this one, so A across to C and up to B. Now it goes from one side of the circumference through the origin to the other side of the straight line, so that's our diameter. So this angle here is 90. You already know this one is 24. So this one is going to be the rest of 180. So 180, take 90, take 24, okay, which is going to give you 66. Okay, hope that helps. And the last bit of this question, I want you to work out BCD. So we've got, let's use this, BCD. So BCD, so we want to work out that angle there. Now if you draw around there, again, same as question 10, you've now got a shape that's got four sides inside a circle, so it's a cyclic quadrilateral, which means that this angle here and this angle here make 180. So we've already got that these two here make 40, 50, 66. Okay, so if those are 66, this is the rest of 180, so that's 114. Okay, I know it's slightly blurry, but this is question 10 from the Corbett Maths one. What it's got, we've got 140 here, and it asks us to prove and explain why angle ABC is 110. Okay, so that's what it wants us to do. Show why that's 110. Now, what you've got to do here is think a little bit outside the box. If you look at these two lines here, alright, now what I can do is if I put a point up out of the way here, I could join those like that, and I've now created an arrowhead. And if you create the arrowhead, we know that the angle at the origin halves to become the angle out of the circumference. So that is 70. And then what we can do is we can go back to the large shape. So we've got a cyclic quadrilateral on the outside, and we know that diagonally opposites make 180. So 110, 70, and that's how we can explain it. Okay, so this is question 10, and what it wants you to do is prove why this is 70. Now, it looks quite hard, but what it relies on you doing is realising if I put a point over here somewhere and join that up there, the red's just become an arrowhead. So because that's 140, this is 70. So 140, this is 70, and something's coming on. Hi, not sure what was the question on this one because the question bit was cut off, but there was a couple of things we can work out from this. Because this is the origin, and we know these are tangents again, we know that that's 90, and we know that that's 90, okay? Which means we can work out this angle here from this triangle. Now, there are other bits we can do here. We could work out an angle here if we wanted to, because we could create an arrowhead if we needed to. I'm guessing it's probably going to be this angle that they want, but if it's not, there are ways of doing it. We know that these two angles here make 180, okay, because these two are 90, and if that's 29, because we know these two are equal, these two are equal, in theory, as long as this is right, then these should be the same and these two should be the same. Okay, hope that helps.